In this video, we're going to talk about the NFPA. And the NFPA stands for National Fire Protection Association. And the NFPA has basically come out with a diamond. And inside of this diamond is going to be information about the chemical that's basically, of course, this is on the label, the chemical that's inside of that container. So the NFPA diamond, I need to say, is designed not for laboratory technicians, not for entry-level chemists, not for laboratory workers, but it's designed for firefighters. And the NFPA diamond is basically a diamond that represents things that these firefighters need to watch out for if this chemical is exposed to flame. That's where this major difference comes from. So the GHS is going to be as it is in the bottle, shipped to you in the container. It is poison. It is flammable. It is noxious. It creates fumes, right? Those are the hazards that the GHS system is trying to relay to you if you've never worked with it before, and it is on the label for that reason. The NFPA label is different. The NFPA label is not how the chemical is in the container sitting on the shelf under normal circumstances. It's what happens if the chemical is caught on fire. That's the difference. So that's why this is designated really for firefighters and that industry and not the laboratory industry. Okay? Inside of this diamond, there's 4 different diamonds. Okay? So 4 different sections that's going to relate to something else. So there's going to be a blue area. And the blue diamond is going to represent health hazard. So if the compound catches on fire, does it create a health hazard? Yes or no? That blue area of the label is going to tell a firefighter yes or no and what kind of steps to take to protect people from it. The red, of course, is going to be flammability. If it catches on fire, is it going to explode or catch other things on fire or make the fire even worse? So the red area, of course, we think flame and hot, and that red area is going to be flammability. The yellow diamond inside of this main one, this is going to be instability. So if it catches on fire, does the thing break down? Does it explode? Does it react more? What kind of things are changing on the chemical level? And do we have to pay special precautions or special attention to it because of that reason? And then finally, there's going to be a white area, and the white area is regarded with special hazards. And a lot of times they will put some kind of abbreviation inside of this white one, and that abbreviation, we need to know what that means. Now, again, it's mainly for firefighters, not for laboratory workers, but it's something that we do see on a label. And we should be comfortable talking about it and distinguishing the difference between the two. As far as the ranking goes, the ranking here is different. We said that the GHS ranking goes from 1 and A, and that's kind of the worst case scenario. And then as the numbers go up, or as the letters go on through the alphabet, it gets less and less worse for us as a user. The ranking, though, with the NFPA diamond is a little bit backward. So 1 to 4 is going to be the ranking, and 4 is going to be the worst. So again, it's backward from the GHS system. 0 to 4 is the ranking. 4 is the worst number for all of these symbols. If a 4 is in blue and a 4 is in red and a 4 is in yellow, then run away from that chemical. You don't want anything to do with it. Okay? As far as the watt area, we said that these are typically abbreviations. There's a couple that we need to know. The OZ is going to be the first one, and this is the oxidizer. Sorry, not OZ, OX. OX is the oxidizer. W can also be listed in that as well, and this means that it becomes water reactive when it's heated up. And then finally, we have SA, and this basically means asphyxiant. Now, let me come up here to the top, because some of you might not know what an asphyxiant is. Asphyxiant. This basically means that a gas is generally produced that forces out oxygen. So it's kind of a bully, and it fills up the room, and it pushes oxygen out of the room, and oxygen cannot get inside, and you need oxygen in order to breathe. So what happens is that with these types of chemicals, you will begin to breathe, and you will pass out, and you will go unconscious because there's no oxygen in the room. That is what the abbreviation SA stands for. Right? So again, this is for the NFPA. It's for firefighters, and it represents basically what happens with compounds if they are caught on fire. That's the difference between this system and the GHS system. Now, you're probably wondering, well, what's so special about fires, right? Well, fires can make compounds do a couple of different things. Number one, you can actually feed the fire. You can actually make it worse. Some of these compounds, if a fire breaks off in a room and these compounds come in contact with those flames, the room can go up in even more flames, even more smoke, and even become more explosive. So you never really want that to happen, and that's the bad news with some of these, okay? The next one, fires can enhance the reactivity. You know, some of these compounds, they need a little bit of heat. They need to be put into a hot tub in order for a reaction to take place. And a fire is the hot tub that's necessary for some of these things to really go nasty and bad. So we never really want that to happen either. And because of that, the chemical properties begin to change if they are exposed to a fire. The next one is decomposition. Some compounds decompose in the presence of a flame. And if they decompose, that means they break down. So they break down and different compounds are released. And maybe those particular compounds, the ones that are being released through this reaction, are the ones that you need to watch out for. Those are the ones that's making the fire worse. Those are the ones that's basically going to give you some type of toxic health effect if you expose yourself to them. So if it's decomposing, we can also talk about combusting. So these molecules can react with flame, and they can combust into products. And when they combust into those products, well, different things can happen. And it's those particular products, or it's those particular side reactions that are going on that can make these compounds worse than what they originally were. So products can be made from the burning. Products can be produced or broken down from the chemical. They can enhance the flame and make it worse, and they become more potent if you put them into a flame. These are the things that we have to worry about when chemicals get inside of a flame or into a hot room, and we have no idea what's going to happen because of it. So that's why the NFPA symbol is out there, and that's why it's so important. Okay. So we're kind of coming to the end of this section, and like always, we end up with a ramp. And the first one is recognize. Well, what do we need to recognize? We need to recognize the lab hazards by reading the labels. The labels are going to be a very important piece of the information to us as a laboratory worker. Second is assess. We're going to assess the risk based on exposure. How did I expose myself to the chemical? Did I breathe it in? Did I put it on my skin? Whichever route of exposure happened, well, is that going to be bad news for me, right? M is going to be minimize. We want to minimize the risk by preventing exposure, and we want to follow GLP, good laboratory practices, and we want to follow PPE, which is personal protective equipment, right? And then finally, P is prepare. So we want to prepare for the emergencies. If something happens and it can become harmful, how do we go in and fix the problem as soon as possible? And are you ready for that? So that is our preparedness. So prepare for the emergencies. Understand how the chemicals can harm you. That's basically what we're talking about in all of this section of the chapter. All right, so that ends this portion of the lecture module. We'll continue on into the next section. The whole lecture module itself is not finished yet, but this portion of the lecture module is. So we'll continue on to the next section. Good luck with your assessment. Good luck with the online test. I think that you'll do extremely well. Just make sure that you take good notes and make sure that you understand what we've been talking about all this time. And I think that you'll keep cranking out those A's.